All right, so welcome to the first beginner's night of the semester. Today we'll be talking about the operating system called Linux. Has anybody here used Linux before? Anybody? Most people in the room should be raising their hand in some capacity. You probably touched it at some point in your life, whether you know it or not. Android phones run on Linux. Lots of things run on Linux nowadays, so it's kind of hard to avoid using Linux at some point. But generally for these talks in general, beginner's nights, they're even less formal than the main meetings, so feel free to shout out stuff if you're confused or if you have a question, just go ahead and yell it out at me and I'll clarify anything you don't understand. Let me know if it's too fast or not enough details. I can help you clarify all that as well. So who uses Linux? According to some sketchy website, about 2/3 of public websites are using Linux as their web server operating system. It's used by lots of developers, sysadmins, people who are hackers or just want to have fun with computers and tweak things, like hobbyists, people who use Raspberry Pis for projects, stuff like that. And lots of research is done with it as well. And as I mentioned, many of you have used Linux in some capacity, whether it's on your phone, your car, your TV, or some smart appliance, it's probably running Linux. So why would you use Linux when you have Windows? Anybody have an idea why you'd use Linux over Windows? We all love Windows, right? Anyone have an idea? No? Yeah. Definitely a lot more control. How about you?
One is more open source, so Linux is open source, Windows and Mac OS are not.
Definitely, yeah. So Linux is an open source operating system, so anybody can look at the code for it. Anyone can try to contribute to the code as well. It might not always be accepted, but there's that transparency there, so you can audit the code yourself and see if it's secure, so you can trust it. If you don't know how to audit the code, someone else is probably looking at it anyway. In my opinion, it's much faster for doing almost anything in terms of development or configuring things or scripting, any of that. It's like the best environment possible when you're in the terminal and the console for that. As someone mentioned, no restrictions. You can pretty much do whatever you want. A lot of times, like Windows won't let you install drivers that do monitor mode for your wireless card. You can't do that on Windows because Windows doesn't allow it. And one of the best things that's not always mentioned is the packages on Linux systems. So most Linux distributions have a package manager. So instead of going out to the internet, Googling how to install some program like, let's say, LibreOffice, you have to Google LibreOffice, go to the download page, press download. On a Linux distribution, you just literally type a command that says install LibreOffice and you're done. And the best part is it'll be updated automatically throughout the life cycle of your Linux distribution. So much easier to maintain and secure and update in that way. So brief history just to give you an idea. So there was once an operating system called Unix, which was at AT&T's laboratories. It was very heavily licensed, so if you wanted to use it, you had to pay for a license or be doing academic research, stuff like that. So some guy, Richard Stallman, created a project called GNU, or pronounced GNU, which was to try to replicate this operating system but make it free for all to use for whatever they wanted without paying for it. So they wrote a bunch of software, all these programs for text editing, programming, lots of stuff like that, but there was one piece missing. The core of the OS was not written yet, so you couldn't boot this system. You could only run the programs on an already existing operating system like Unix. So this guy, Linus Torvalds, wrote a kernel. So the kernel is the core of the operating system, the part that talks to the hardware, manages memory, disk I/O, stuff like that. And so Linus Torvalds wrote this thing called the Linux kernel. It's a combination of his name and Unix. So the Linux kernel was born in about 1990 or so, I believe. Yeah, by the 90s. So once that was done, you could finally run these new components, and it was all free for anyone to use for any purpose. And to this day, he still is the lead developer for Linux, and lots of people contribute too. So a lot of times I hear, well, what does Linux look like? Question?
Doesn't like Mac OS still run on Unix-based?
So Mac OS is Unix-based, yes. Yeah, but it's all still a closed source and proprietary stuff. But it's not Linux, it's Unix-based, yeah. So a lot of times I hear questions like, what does Linux look like? Does it look as good as Windows, or what's the graphical side of it look like? Well, Linux doesn't really have a look. Linux is a kernel. It's not anything graphical. It's all low-level stuff that the system code. So I guess if you want to know what it looks like this. This is output from the kernel, so nothing exciting. But more commonly, you'll have a desktop environment on a Linux distribution, and some of the common ones are like GNOME 3. It's default on a lot of distributions, and so these are running on top of the kernel. They're in that user land area. They're not part of the core OS. So There's GNOME, KDE, LXDE, XFCE. There's a bunch of these. There's so many, can't even count. Or if you want something less complicated, there's just window managers that don't have the whole environment, and this is i3. Just some examples of things you could have. There's so many out there, can't cover them all here, but so technically, as I mentioned, the kernel is just the core of the operating system down here, and all the stuff that runs on top of it isn't actually part of Linux. So there's always confusion when people refer to Linux. So what you actually have is made up of the GNU or GNU userland stuff. So all of your graphical programs, your desktop environments, all of your software that you actually interact with is not Linux. It's actually part of GNU or whatever package or whatever person made it. So just a little clarification there with that. So on Android, you run the Linux kernel, but everything you see and interact with is not Linux. It's part of the Android OS, which is all written in Java and stuff like that. So, okay, we talked about some of the basics. How do you get it? Well, there's a bunch of distributions that are put out there. Each distribution they're pretty similar. They each have their own sets of packages, their own default settings, their own default graphical environment, stuff like that. They're not too different. A lot of them have different configuration options and stuff like that, but they kind of blur together after a while. So there's some of the common ones. Debian is what I personally use. Ubuntu and Linux Mint, which are based on Debian, are often good for beginners. Other ones, Fedora, Red Hat, and CentOS. The school, Iowa State, uses Red Hat for their Linux servers and workstations. OpenSUSE, don't even get me started on OpenSUSE, and Arch Linux, Gen 2, stuff like that. So there are many ways to get started running Linux. So one way is to use the new bash on Ubuntu on Windows 10. That's one way. You can also dual boot, which means your laptop or your computer will have multiple operating systems on it. So you reboot into another operating system. Kind of a pain, but it's definitely doable. One of the easiest ways to get started is to spin up a virtual machine on your computer using VirtualBox or VMware Workstation. So you don't have to actually install anything on your actual computer. It's all virtual. Or the best way to actually learn Linux is to wipe everything and just install Linux on there and force yourself to learn that. Alternatively, we can do it on a remote server, which kind of goes to our next part here. So if you have a laptop on you and want to follow along, you can do so, as we'll be doing some interactive stuff here. So Iowa State provides several Linux servers for remote access for multiple purposes. If you are an ECPE student in computer engineering, electrical engineering, or software engineering, on the right here we have linux-1-7.ece.iastate.edu. They even have a nice thing on their website that shows which ones have which software, how many users are on there, and what the load is of the system, so you can choose which one to use that way. If you're not in ECPE, there's a bunch for all engineering students as well. On the left here, Linux Remote 1-5 at engineering, iastate.edu. And I'll put these back up if you need them, but so if you want to follow along and play around with some Linux stuff here on the school servers, we have, first of all, for Windows, you can download PuTTY. It's a free open source SSH client. So you can go ahead and get that if you want to SSH in from Windows. If you're on Mac OS, I don't know if anyone here, is anyone on Mac here? Okay. Well, on Mac, you can just open the terminal by searching your applications, and SSH, since Mac is a Unix OS, it should have the SSH client already on there in the terminal, so you can just type in SSH, your NetID at Linux, whatever the host name you pick there from the list here. And if you're on a Linux system already, well, I think you might know what to do, or you can either do this as well, since it's the same thing there. So let's get started. Let's look at some actual usage of common Linux userland tools. So first of all, most importantly, is how to find yourself. Where are you at? How to get started working with files and directories and stuff like that. So you've probably all heard of CD, how to change directories. Pretty straightforward there. Make this all bigger. Yep. So we just changed directory into one called IASG. Most importantly, or second importantly, is ls to list files. Lots of files in there. You can do other stuff like long listing to see permissions. We'll talk about that later a little bit as well. And lastly, on this slide, pwd shows what directory you're currently in. So I'm in my home folder, home, keen, IASG. So those are just pretty basic for moving around on the operating system, seeing where files are at, looking at what they are. And so to explain how the layout is, you got the slash, which is the root directory. Everything is in a tree structure underneath that slash there. So some of the common directories, slash bin is where a lot of binaries are going to be, so a lot of system binaries. Boot is where the bootloader goes, so that's usually called grub. In dev, that's like it's called a pseudo file system, sort of, where all the files correspond to devices and other things like that, since on Unix, everything is a file. etc or etc is where most of the config files, most of the configuration files go for software you install. So a lot of time is spent in that directory editing files and changing configurations. Slash home is where your home directory is. So as you saw, we were in my slash home slash keen directory, which is my home folder, home directory there. Lib, libraries, some other important ones. sbin is where some other system binaries go. So commands that usually require administrator privilege are going to be in that directory. Besides that, temporary directory, tmp. var/var is where variable files go, mostly important for logs. If you want to check a log, something's not working, you can read the log files out of there. Root/root is root's home folder. Root is the administrator user on the system, which has pretty much all of the power to do whatever they want to the system. And lastly, proc/proc, which you might not find on all systems, is another virtual file system that has lots of information about the hardware, processes, and stuff like that, which we might get into later at a later date. So a lot of using Unix-like operating systems is just learning how to move around and fly around the shell using tab completion and the up arrow. So a lot of times I see people typing in really long paths and struggling trying to find file names and stuff like that, but really they make it pretty easy for you with modern shells like bash, where you can just use the tab key to complete very long paths. So let's say I make a huge nested folder structure like this, a bunch of directories inside each other. It would be a huge pain to try to type all this out later to get, if I want to get in the directory, right? So if I wanted to cd, I'm not going to sit here all day and type in all those letters. I'm going to hit tab and it's going to complete it for me. So I can just keep hitting tab and it'll magically type all of that automatically for me. So there I am in that really long directory. What if I want to go in there again and not even have to tab complete again? Well, I can use the up arrow to see my command history. So I can just go back up since I know I was already in there. Oops. So I already did this command. I can just hit up arrow until I find it and do it again. So that really speeds up your time working on these operating systems, and especially tab complete. If you're ever typing more than a few letters, just start hitting tab and it should take care of most of your problems there. So working with files, you may have seen this before as well. Some basic ones: copying a file, CP, source destination. The periods are there, the ... meaning you can put multiple files there and it will copy or move them all. If you're doing directories, working with directories, you have to do -r to specify that you want to recursively copy. So that means you want to copy the directory and all the files inside it as well. With move, you don't need to do that option because you're just moving. Same goes for rm. Rm will delete files. Never do rm-r/. That'll potentially delete your entire file system. And with that, the recursive option as well. So if I wanted to delete one of these long directories, I can do rm-r. Well, it's kind of going over the side there, but I think you can see it. Then I'll tab complete the last folder directory in there, deleted that. I can also copy stuff. So I want to copy this folder, this directory here, to my new folder. It'll complain since I didn't do -r. So I can do -r and it will work. And now if I ls, I have two folders in here. There's the new one I just made. Same thing goes for moving. My other folder, just moved that folder there as well. So pretty straightforward there. Now basic working with files. If you want to create an empty file for whatever reason, you can do touch and then the file name. Touch is also useful for updating when a file was modified. So if a file already exists and you touch it, it'll update the file's modified time to now or whenever time you specify. So we can say touch this file. I guess I should, as you can see, this file doesn't exist. I'll touch it now it exists. You can also make a directory, as you saw earlier with makedir. That's how I made all those nested directories. Reading files, one of the most basic tools for this is called cat, which is for concatenate. You can do cat followed by a number of files. So I could, let's see if I have any readable files in here. So I'll cat this Python file I have sitting in my home directory here. So you can do that, or if you have multiple files you want to concatenate together into one output stream, we can do, here's like a HTML file, I don't know what it is. Oops, nope. So you can see here it printed out this HTML as well as the Python above it. So that's cat. If you have a really long file you want to read and don't want to have to scroll through the mouse or risk going off the screen or something, you can use what's called a pager. And so less is pretty much the standard pager tool you can use on GNU Linux systems nowadays. So we can do less followed by, what was that HTML file? So this lets me scroll up and down however I want. Not much to scroll in this file, but you get the idea. It's especially useful on like log files. So if I wanted to look at my system log file and /var/log syslog, typed that wrong. Excuse my poor typing. Okay, I'll give up. Can't type under pressure. I'll read the mail log. Nope. Permission denied. What can I read in that directory? Oh, there we go. So you can see here I'm scrolling through this long file here. You can even search for stuff too. This is about my display server stuff, so nothing interesting there. We can also, if you want to look at the bottom of a log file, we can use a tool called tail, which kind of does as it sounds. It'll give us the tail of the file. So by default, I think it reads the bottom 10 or 20 lines, I forget. But I could do that with the same file, and it will give me just the last, I guess it's like 10 or 15 lines or so. The cool part about tail is if you want to watch a log that's currently being written to, so let's say we want to watch like the authentication log to monitor incoming connection attempts in real time. I'll try this again. Oh my God. I can't type it. When you're picking passwords, make sure they're typable. There you go. So if I do a -F at the end of that, it'll watch this log for me. So let's say I tried to connect to this system. You can see that log started scrolling down there as I tried to connect to this computer. So that's useful for monitoring logs. In addition to tail, there's also head, which you can probably imagine instead of the bottom of the file, it looks at the top of the file. So pretty useful as well for some things if you wanted to see what's at the top of the file and ignore everything else. It's good for that. So editing files on a lot of systems, you can just type in the word editor followed by a file name, and it'll open your default editor. May or may not work correctly, but usually there are several common editors that you'll have on a system. You'll pretty much always find Nano on there. I don't really care for Nano, but it's pretty basic and easy to get started with. All the commands you need are right on the bottom of the screen. If you want to go more advanced, there's editors such as VI or the more advanced version Vim for VI improved. Also Emacs. Both of those tools, VI, Vim, and Emacs, are very powerful. Lots of cool stuff you can do with them. They have huge plugin libraries. You can pretty much turn them into full-fledged IDEs if you want. And they'll do like syntax, highlighting, and stuff like that for all your programming needs. So I'll just I guess I'll show them off here quickly. So Nano, as I mentioned, I don't really use it. I don't even know if I have it anymore. So I can do nano lol.txt, and I can just start typing in here, and all the stuff's at the bottom. So if I want to exit, Control X, save, yes, done. Vim is a bit more tricky because, well, at first it looks completely confusing at first, but that's how it kind of goes. So really there's no help on screen at all. There's just Daniel, really? Anyway, if you start typing it'll kind of just make a mess. There's different modes you have to worry about, but if you're ever stuck in VI or Vim and you don't know what to do, if you press the key I, it'll put you in insert mode, which is just normal typing mode, and you can start typing there. Otherwise, you're in normal mode, which is for commands and navigation only. So let's say I open, and I really should turn that off before starting a presentation, shouldn't I? I thought about it. So many files called test something in here, it's ridiculous. So I've added this file. I can go up and down, but I'm not in edit mode since it doesn't say insert down there at the bottom. But if I press I can start typing. There's of course a bunch of other commands that make it very quick to use Vim. You can even do macros and stuff like that. I've become pretty quick with it over time, but there's a steep learning curve at first. Emacs I know nothing about. Anyone ever use Emacs in here? Yeah, I don't really know much about Emacs, but I know it exists and does a lot of stuff too. So if you're stuck, use Nano, but otherwise I encourage you to try to use Vim and force yourself into learning it. That's kind of what I had to do one summer. I just told myself no more Nano, learning Vim this summer, and eventually it paid off. So now we'll talk about file permissions and ownership. Any questions so far on anything? I'm kind of going fast probably, but any questions at all about what we've seen? All right. So file permissions, as you're probably aware, files have permissions on them to control who can read them, who can write to them, and who can execute them. So if we use ls-l, we get a long output, long listing format of ls, and it will show us, in addition to the file names, as we saw before, it'll show us the permission bits, the ownership, and other information like the size, the modified time, etc. So on the left here, we can see all these letters. The D in front stands for directory. So those are directories we could CD into if we wanted to. On the right of that, we have RWX and various combinations of that. So the R stands for read, W stands for write, and X stands for execute, as you might expect. And in the middle here, we can see it says keen and then keen. Well, this one is the user who owns it, and the second one is the group who owns it. They both happen to be the same in my case, since my group is the same as my username. This here is the file size, so those numbers in the middle are the file size in bytes. We've got the modified time here. Some of these are pretty old files, I guess. So as you can see, there are 3 sets of RWXs over here, and the first one's for me, the owner. So I own all these files, so I have, like on this directory here, I have read, write, and execute permissions. But next to it, it's all dashes, meaning no one else in my group or on the system can do anything they want, do anything at all to that directory. But down here, we have these other directories, like this one called workspace, where, again, I have full control of read, write, execute over it, since I'm the owner. The group, keen, has only read and execute permissions, and everyone else in the system has only read and execute as well. So they could go into the directory, but they can't create new files inside it, I believe. Yes. So as you saw there, we won't see it quite yet, but there's another way to notate these permissions. So we saw RWX and stuff like that. There's also an octal format that's used pretty commonly. You might see that around a lot. So the read bit has a value of 4, the write bit has a value of 2, and the execute bit has a value of 1. And so you'll see down here some examples. So if you have permissions 777, it means everybody, so the user, the group, and everyone else in the system can read, write, and execute. But if we go down to 400 here, that means only the owner can read it. Or if we had 440, that means the owner and the group can read it, but no one else could. So it gets a bit tricky at first, but you catch on to it after a while, and it becomes easier to work with commands and files that use these permission bits. But we'll kind of skip that for now. It's not too critical, but you'll see it more later probably. So we talked about the permissions. In order to modify them, there's a couple commands we have here. I think I forgot one of the slides there, but anyway, if we wanted to change the permissions on a file, we have the chmod command, which stands for change mode. So if we wanted to make a file have RWX, RWX, RWX for everyone, we could do chmod 777, as I showed on that last slide here with those permission bits. Or you can do the more, I guess, more readable version, which is chmod, and then UGO, which is user, group, other, and then we're adding permissions, read, write, execute. So that does the same thing as 777. So maybe a little more readable, but depends. If we want to just make the file executable, we could do chmod 755, which makes it read, write, execute for us, and read, execute for everyone else, or simply +X, which just adds execute for all possible users. And lastly, at the bottom, another example there as well. I forgot to write a slide for this one, but there's also the chown command, which changes the owner. So as you saw, these files are all owned by me, but if I wanted to change ownership to someone else for whatever reason, actually, let's see if I have this, yeah. So I can change, let's see, I'll change wi-fi.txt. So it's currently owned by me, but I can do chown to make it owned by root only. I guess I'll just do that. So now if we look at that again, you can see I changed the ownership of the, I changed the user to root, but the group is still the same. So if I wanted to change the group as well, I'd have to do root:root. So now it's owned by the group owner and the user owner are both root there. And so now you can see that I can still read the file because my user falls into this category, the everyone else category, and I still have read permission. So I can try to read that. I'm not sure what's in this file. Okay. If I were to chmod that file, so only root could read it, I could do 400 wi-fi.txt. Now if I try to read it, I can't. Permissions denied, because that file is now just read for the owner, which is root. All right. Any questions on the permission stuff? I know it's a bit tricky to look at, but all right. And so lastly, we have some stuff here for kind of looking at users on the system and stuff like that. So if you want to see what user you currently are, you got a couple options there. You can type ID, which shows a bunch of stuff about your user and what groups you're part of. You can also just say more simply, who am I? ID has a bunch of other options. You can look at other users too with it. So I can look at root. Root is always UID of 0. A kind of fun one that I'm sure Iowa State doesn't really like us doing on their servers is wall. So if you type in wall and then a message, it'll be sent to everyone else on the system. So kind of a fun one, especially when you send like Star Wars ASCII art over wall and someone else gets it dumped on their screen. So don't do it too much on someone else's system, but people seem to have fun with that one. And there's also write, which allows you to do the same thing, but just to one user that you're trying to send a message to. Those aren't really used very often in the wild, but kind of fun to play around with, I think. So if I wanted to, is anyone on one of the Linux systems right now? Which one?
I'm on number 1.
Linux-1?
I'm in the research one because
I think I'm, my home directory got nuked today, so I don't know if I can log in quickly anymore. But while that's logging in, I'll look at other stuff here. So we've got some stuff to look at processes on the system. So if you want to see what processes are running currently, you can do ps aux, and that gives you a giant list of all the processes that are running. So we can scroll through that. So on the left, you can see who owns the process. There's root owns it there. That's still not logging in. Wow. The process ID or PID. You've got how much CPU it's using, how much memory, and this is all a snapshot from when I ran it. So this is not updating in real time here. And on the right, you can see what the actual command is. So a lot of stuff in the kernel here in those brackets that we don't really care about too much. But down here, under my user on the left, that might be more interesting, more relevant stuff. So like I'm running GNOME, which is it's basically what this graphical environment is. Lots of processes from that. It's a huge resource hog sometimes. Google Chrome's running on the right here, stuff like that. You can see useful for debugging, what processes are running on the system. Are there any malicious processes running? Stuff like that. You can see by running commands like ps, You can also give it a process ID, so if I wanted to just look at this process, for example, it would just show that one. Wow, this is not working. Besides that, you can do top, which will show like a real-time updating version of that sort of, where this will refresh every few seconds and show us what's currently happening on the system. So right now, Slack is eating up apparently 15% of my CPU. That's kind of concerning, actually, but whatever. That's typical for Slack nowadays. But this is pretty nice. You can scroll through it. You can sort it different ways. You can even kill processes from it by pressing K. You can sort by memory usage. You can look at the individual CPUs. It has lots of cool information if you want to monitor processes and resource usage. There's also a better, well, slightly nicer looking version called HTOP, which has some nice bars at the top that show each core and the percentage of memory used and stuff like that. So pretty much the same thing, but a slightly different interface. So if I wanted to kill Slack here, I'm going to killing Slack. No more notifications, Daniel. Yeah, apparently I can't log into the ECPE servers anymore. That's kind of concerning, I guess.
Try using 6 on bullet restricted just to ECPE.
What are they called again?
It's the same thing, but it's 1 to
Oh,
5 is
gotcha.
the bullet, 1 6 on it.
Oh, there we go. Well. I guess no one gets to wall me while I'm up here then. Oh well.
Waiting.
It could still happen. Anyway, so if you see a process you don't like or it's running astray, it's taking up too many resources, you can try to kill the process. So let's say I have a process. I think I have one running currently that's called annoying or something like that. So, yep, there it is, annoying process. So if I wanted to kill this process, I could either do kill followed by the PID, which is that. I could do, or even easier, I could just say pkill and the name, annoying process. And that even completes for me automatically with tab, so I can kill it. Now if I'm look at that again, no longer running. Wow. I'm going to try real quick to log on to the other one. Can you spot the typo? Okay. Daniel, want to log on to that one too? You can also do kill all to kill all processes. So let's say I had a bunch of Chrome processes open or something. I could do kill all Chrome, and it would kill all of my Chrome windows, all that. I won't do it right now since I'm using Chrome for this presentation. Oh, there we go. Daniel just used the wall command on this server. So everybody who's currently logged into the server got this message, hi. They got their session interrupted to see this very important message, hi. So if they were working on a big text file, it might have kind of just destroyed their view, made it hard to see what they're doing. I'm sure they get pretty mad if people do this quite often, but let's see. There's only like 4 people on here right now, so it's not a big deal. But a lot of times on the ECPE ones, you'll see like 20 people on there at once, and if you do this, you know a lot of people are getting mad right now, probably. Someone else is on there? Cool, yeah. I'm trying not to abuse this too much. I wonder if the choo-choo train can go through that still. All right, so we talked about killing processes, not murder. All right, lastly, so if you're stuck, you don't know what to do, don't know how to use a command, the man pages are there for you, so you can almost always, you can type man followed by any command. So if you wanted to look closer at the PS command for looking at processes, we do that. And we get a nice, helpful man page of all the commands you can do and all the options, how everything works. What's even nicer about man pages is if you're doing any C programming or C++ programming, stuff that uses the standard libraries for C, stuff like that, all of those libraries and system calls are going to be in the man pages as well. So let's say you're doing socket programming in C, so doing network sockets. You can often type man socket, and you'll get the C library documentation for the socket library, which is super useful. You could just Google search it too, but when it's right there on your system, it's pretty easy to read. So even if you're doing like printf, it's all going to be, it's all right there. Oop. Yep, nope, wrong one. Sometimes it defaults to looking at like the shell command man page. So if it's a library, for sure you either have to do 2 or 3. It's going to be 3. So yeah, 3 in front of that. So I get you get what headers you have to include in your C program. That's nice to know. If you don't know what to import or include, you have that right there, and it tells you all the different variations of printf and stuff like that. Super helpful there, and all the gotchas and caveats are going to be in there for that as well. Further, there's also what is. So I can say what is ls. And it tells you exactly what it does. Or I can say, what is, if you type in something that doesn't exist, it says nothing appropriate. What is bash? It's a shell. That's useful for getting a simple description of what something is. You can also do where is to find out where one of those programs is. So where is ls? And it finds all the places where the file ls is. So the first one here is where the actual program ls is, and the second one here is the man page for ls, it looks like. So that can be helpful depending on what you're doing. There's also which is kind of similar, although it'll show which version of that is in your path. So I can say which ls, and it shows that ls is not pointing straight to bin ls, but it's alias. There's an alias for it, so it actually is going to run ls and some options that turn on the colors for it. So nothing too exciting there, but it's helpful to find out where stuff is on your system if you're trying to find where something's at or why something's broken. And also, most commands have a -h flag, which usually show less information than the man page, but still pretty useful. So ls-h actually is a different option. That's for showing human readable file size. Never mind. If I do ps-h, nope, that's also a thing. So if I do top-h, we saw top earlier was this interactive process list shower thing. If we do top-h, we get a really short usage help right there. So just the options to pass to it to get it running there. A lot of times they'll also have -- help, sometimes in place of the -h or in addition to. It's kind of confusing per program. Actually there, it didn't like that at all. It errored out and showed me usages that didn't exist. So you just keep trying those sorts of things. And lastly on this page here, if you're ever completely stuck in doubt, just type help, and you might, I guess not here, but I think bash will help you. Help. So lots of stuff built into the system to help you, lots of stuff out there on the internet too if you search for stuff. Definitely a lot of stuff on SuperUser, one of the Stack Exchange sites. Server Fault has a lot of stuff if you're ever working on something and just can't get past it. A lot of people on there have already had the same problems and have solved them, so definitely search on the internet if you have a problem like that. Any questions at all on stuff we talked about today? A lot of it was pretty basic stuff, but it definitely builds the foundation for moving on to more advanced stuff that requires you to be more familiar and comfortable using these tools and systems. So any questions at all about stuff? No questions? All right. Well, I believe next week we'll have another beginner's night on intro to networking. So I believe Cole is doing that. So we'll see that next week. If you have any further questions, hit us up on Slack. Also, the slides and the video should be posted online. All of the slides for all of our talks end up on our Google Drive folder, and you can find that link on our website or in Slack. So if you ever want to go back to these presentations at all, they're going to be on those links there. So thank you.